Hello and welcome back. So we went over variables, input and output, mathematical and logical operations, conditional execution, and repetition so far. And now we are moving into the foundations of functional programming in our sixth video. So let's go and create another section in our script here, in our tutorial. We're going to call this user defined functions. So let's go at a high level here. So functions, or functional programming, the idea is to enclose specific sections of code that provide functionality, specific functionality, to the program. Think of functions as sub-programs, as modular sub-programs. In user-defined functions, when we define a function, we are adding functionality, in this case, to MATLAB. In a user-defined function in MATLAB, these functions behave exactly the same, just like the built-in functions. And we want to design them in a way that they behave like the built-in function. So what are some of the advantages of using functions? Whether they are the built-in functions or the user-defined functions that we will put together perhaps in our own toolboxes. Now, a collection of functions is a toolbox in MATLAB. It may be a library in another programming language. Why do we use functional programming as opposed to just solving the entire problem that we are trying to solve with our program in a single file, in a single function, so to speak? Well, number one, by adding these functions, right, we can add a specific functionality that can be reused over and over again. So if there is something that you need to use many times, well, that's a good idea that probably you should create a function, especially if it is going to be useful not just in this particular program that you may be creating, but in many other programs. And this is something that you can think of all the built-in functions that we have in MATLAB, whether we are talking about mathematical functions like sine, cosine, or the mathematical functions, to functions to compute statistics on data, mean, standard deviation, etc., to functions for plotting, to functions for signal processing, filters, FFT, etc. These are functions that are not only useful in a particular program where you need to use them, but they are useful for users across many programs across many programs. And so functional programming encourages reusability. That's the first advantage. Second, functions make programs much easier to understand, much easier to actually code because you are reusing other things, and also much easier to debug, troubleshoot, and maintain. Okay. Third, one of the advantages of functional programming is that, well, you can divide workload on larger projects among programmers by working on different functions with well-defined interfaces. This is also why open source works very well in the context of software, as long as you know the functionality that you want to create, what are the inputs, and what are the outputs, effectively how the function should behave, meaning as long as the interfaces are well defined, you don't have to worry about the actual definition of the function, how the function went about accomplishing that output from those inputs. You just need to know what the function does. And so many times when you're using a built-in function in MATLAB, for instance, well, you just know that these inputs are going to give you the output. You know what the function does, not how it does it. And that's a principle of well-defined functions. Now, as you group functions together, you can create a library. In most programming languages, you will call that a library. In Octave, you call that a package. In MATLAB, it's called a toolbox. Like the signal processing toolbox is just a collection of functions that people put together, that were put together to solve signal processing problems, the type of functions that are useful. Same thing for the controls toolbox, same thing for the statistics toolbox, same thing for the machine learning toolbox, etc. So what are some of the key concepts that we're going to go over? Well, how do you declare a function, a user-defined function? How do you define it? Some concepts like variable scope. What happens to those variables that you define inside a function? Function arguments, like the input and output parameters, and the fact that you are passing ordinarily these input arguments by value. So with that, let's create a function. Any function, incidentally, that we used before, like we just use here cosine, for instance, that's a function. We can say help cosine, and we know that, okay, you put a value x, it will give you the output, right? So that's a built-in function. Like I said, let's do cosine of 1. It will tell us, or cosine of 0. 1, cosine of 1. It also behaves that if you put a vector, right? Those are the input parameters. Let's do 0, pi over 2, pi, 2 pi, provides us the output. So these are built-in function. So let's create a function, for instance, that given two numbers, or actually better, given two matrices, it adds them and it multiplies them. So to create a function, the first thing that you need to do is to, well, create a file for it. And now let's go ahead and declare that function. Think of a function as a subprogram, or actually you could think of it as a program that solves a particular concept. So to declare a function, you use the keyword function. I'm going to say, well, then you write your output variables. And to denote S for sum, P for product. I'm going to say, I'm going to give that name to the function, add, multiply. This should be a name that does not exist in MATLAB. And then you have the input parameters. I'm going to say X and Y. Okay, so in this function, the user is going to pass X and Y, which can be two matrices, and it will give the output the sum of X plus Y and the product. Okay, now let's talk a little bit about documentation. It's a good idea to write the function name, add mult, and then what it does, in this case, computes the sum and the product of two matrices, which could be 1 by 1, meaning it also works for scalars. It's a good idea to, in the documentation, write the function call, meaning the name with the input parameters and the output, and then provide some documentation as to what happens with the inputs, what are the input variables. And to say, in this case, X is my matrix input 1, Y, and matrix input 2, output variables. S is the sum of the matrices. S is equal X plus Y. P equals the product of the matrices. P equals X. And this is the matrix product, actually. We want to put something like a version. Now, it's very important that you adopt a particular documentation style that is also consistent with some of the other documentation that you have in MATLAB, that the functions behave more or less like the other MATLAB functions, meaning can accept vectors or matrices, etc. If you are creating a set of functions in a particular domain, like in signal processing or in medical signal processing, or for renewable energy, some of the students in renewable energy, whatever it is, your domain, you will want that there is a consistent documentation and a consistent behavior. Those are some of the elements of good function design. So this is a very simple function to illustrate just the concept of function. Of course, you can apply this for any other function that you will want to create. Okay, so with this will be the declaration and the documentation, and then let's define it. Now it's the code to actually solve this problem, which in this case is as trivial as it can be. S is equal x plus y, p is equal x times y. Okay, so this will be the function definition. This is the function declaration. This is the comments, that is the documentation for the function. These variables, when we enter an x and a y, which will be a particular value, a particular matrix, those are passed by value. All the variables that are contained within the function, we say that they have local scope, meaning they do not affect the variables outside the function. That should make sense, right? When you are using some function out there, you want to provide inputs and it gives you the outputs. You pass inputs, it gives you the outputs. All the computations that it did internally to solve that problem, you don't want that if the same variable were to be used in your program outside the function, that it will have changed that value. So again, the variables that you define over here are not going to go to the memory outside the function. They're not going to affect the workspace. Okay? They are local variables. So with that, let's go ahead and give it a name. Save. I'm going to call this add multiply. Automatically is going to choose as the name of your program, of your function, what you declare already, add mult. So save it. Once you have done that, as long as the function is in your path, or you're working in the current folder, like in this case we have this add mult, if you say help add mult, it will display the documentation that was typed in the function. Much like when you say help fprintf, a function for input output, it provides the documentation, etc. Now it is also a good idea to, in the function, include some example, if it is a complex function, of how will it work, that somebody can just evaluate that section of the code, as in this case, right? So let's go to the workspace. We don't have any variables in the workspace. Help, add mult. By the way, if you type tab, it should, or anything that starts the same will appear there. So I'm going to say add add mult, right? We got it. And so let's go ahead and just call it add mult. If we do this, it will give me an error because there are not enough input arguments. It needs at least two values or two matrices, add mult. If I do 5, 10, now remember this adds matrices, but 5 and a 10 is like a 1 by 1 matrix. It should give me the result, but in this case, what result? Because I didn't give a particular output, right? So what it's giving me is the first one here, is giving me the sum. If I wanted both of them, what I need to provide is s, p, and output arguments. If I do it like this, it will give me the results. The sum is 15, the product is 50. Notice that the reason why those were prompted at the output is because I didn't use the semicolon. If I use the semicolon, nothing happens. Incidentally, let's go over this business of local variables. When I call the function, let's imagine that I say here, okay, now x equals my notice what I call here the variables that I use internally in my function, the x and the y. They don't have to be the variables that you use externally because you are passing by value. You are just passing the value, meaning I don't have to say x equals this, y equals that to use this function. I could say a equals, say, my 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have my A matrix. My B matrix is, I'm going to do a matrix of ones, 1, 3, 3. And I'm going to call the function. The same way, I don't have to call the output parameters S and P. It can be anything. That's just what is used internally in the function, which is then is also passed by value. So I'm going to say, for instance, sum product equals add mod A, comma B. Again, notice A, B, what I'm passing is these variables, these values, A and B, to be the X and the Y, that then X and Y are used internally in the function, added and a product, to create the S and the P variables that then are passed to the output, but in the output I can call it anything I want. So in this case, if I do something like this, what do I have? A, B, product, and sum. Notice that X and Y are not in the workspace, S and P are not in the workspace. They were local variables to the function. They have local scope. This is different in a script. In a script, anything that you define goes to the workspace. In a function, it doesn't. And that's important. And it should be done that way, because otherwise when you call a function, if the function were to use the same variable names that you had in the script, potentially it will rewrite those variables. And you don't want that to happen. You want the functions you want to communicate with functions just through the interfaces. The input, you provide an input and it gives you an output. So sum product. Now, since MATLAB uses the matrix as a very fundamental and foundational data structure and vectors that then will allow you to do vectorization, for instance, etc., you will want that the functions that you create will behave like other MATLAB functions, so that users do not say, well, what happens with that behavior? So this is the concept of a function. Once you have it created, you can use it. So I'm going to go back to my code here. And as an example, I'm going to do exactly what we did here. We are going to define a variable A. We are going to define the variable B, and then we're going to call the function. And in this case, function, we added functionality. So now MATLAB has another function. So you can have your own toolbox, your own library of functions, either generic functions that you use in your engineering practice, or by discipline or specialty that you have created. So let's run this. Let's run this section of the code. So we have A, B, the sum, and the matrix product here. as you can see, we just added functionality to MATLAB. Help add mode. And you have a function that you added. If you add a significant number of functions in a particular field, you are creating a toolbox, and they can be related among each other. You can have the setup, etc. Otherwise, just make sure that these functions, in order to use them, either you're working in the directory where you set the function, or otherwise set the path, add it to the path. Okay. So even though this function is really simple, it really helps illustrate how do you declare the function. You need to use the word function. You give it a name, provide inputs, and you define the inputs you're going to have and the outputs. Should also include documentation. That documentation appears when you type help, the name of the function. You need to save that function with the name that you have given to the function, a file with that name, so that then you can call. You can either call it in the command window or you can call it within a program. Because of that, now it's going to be able to be reused. Of course, it's going to make your programs easier to understand. If you're working on a large program, just define the particular sub-problems that you need to solve, the sub-programs, the modules, and then you can work on those independently. Now, if you're going to work with other people, this idea of divide and conquer, all you need to define very well are the interfaces. What are the inputs and what are the outputs? Okay? As long as the interfaces are clean, the documentation is clean, you don't care about effectively how the function went about solving a particular problem if you're going to reuse it. And remember, as I mentioned, all the variables have local scope. Okay? Thank you.